Welcome to the lesson on perimeter. In this lesson, we will discuss some of the basic applications of perimeter and how we can find a perimeter of figures when they're on a graph and missing numbers. Now, perimeter is a distance around a closed figure. It's measured in basic one-dimensional units, and it's also very important to realize that with perimeter, we may not always have the measurements of all the flat sides. So we're going to take a look at a figure that's on a one-unit grid. So as I try to find the perimeter, I know that essentially all the vertical and horizontal parts of this figure will all simply be 1. So if I'm able to count all those up, I know that that portion of my figure is 8. However, all the diagonal parts will not be 1 and can be found by doing a simple Pythagorean theorem problem. So 1 squared plus 1 squared is going to give me 2, but if I take the square root of 2, I get a decimal, so I can essentially leave it as the square root of 2. So every diagonal portion of this figure will be represented by the square root of 2. Now, rather than trying to add all these up, I can simply count the amount that I have, and I can look and see that I have 7 square roots of 2. So my final answer could be 8 plus 7 root 2. But as I do some of the math, I put root 2 in a calculator, times it by 7, I get 9.89, and then I can leave it as 8 plus 9.89, which will give me about 17.89. Now, by looking at some other figures, I get what looks more like a blueprint, or perhaps a building and office, where I have a lot of the measurements available, but not all. So I must use a little bit of math, a little bit of deduction to find some. I know that the top 5 horizontal sections are going to essentially be the same as the entire bottom section because they all add up together to be the same as the bottom. So all 5 of those at the top are 2.79. Now I must find CD. In order to find CD, I know that CD is essentially this distance from C to F and FE. So to find that distance out in space from C to F, I'm going to take IJ, 1.25, and subtract GH, 0.89. So I'm going to get 0.36 and add 0.42. So that section CD is 0.78. So now it comes down to carefully adding up all the parts. So 2.79 plus 1.94, double that up, plus another 2.79. Now the small sections, 0.78, 0.42, 0.89, and lastly, 1.25. So if I add all those up carefully, I will get 12.80. Let's take a look at another practice problem and go back to the dot diagram, but instead of the units being worth 1, they're going to be worth 5. So again, all my horizontal units are worth 5, and there's only 2 of them. The remainders are diagonal. So I make another small triangle where I can apply Pythagorean theorem, get 5 squared plus 5 squared, so that's going to give me 50. Which would be the square root of 50 for those sides. So I'll go ahead and label each side square root of 50, and I'll just put dots instead of writing the square root of 50 that many times. But after I count the dots, I know that I have 10 root 50s. So my answer could be 10 plus 10 root 50, but I can go ahead and put it into a calculator to get an approximation of the answer. So I get 10 plus 10 times 7.07. Times 10 will give me 70.7 plus 10, and I'll get 80.7, about 80.7. So let's take a look at another practice problem that have me looking at another floor plan from what it looks like. So I'll go through this problem and first determine what I might be missing. So I am missing BA, and I do know that CD is 0.46, so if I subtract that from QR, I'll get that BA is 0.97. As I keep going, I know that this whole section, those 4 sections here on top, gotta be the same as the bottom, so that's gonna be 3.69 for the whole 4 top sections. And these 2 other little parts will also be 0.51, including this little section here should also be 0.51. Now I do have this remaining section here on the right, and it's also gonna be 1.8, just like FE. So now that I have everything, I can create a list and add that list together. So I'll have 1.43 plus 3.69, and I'm just going around the figure here, plus 0.97, 0.46, 1.8, Then I'll add in the 4 instances where I have 0.51, add the second 3.69, and then lastly add the last 1.8. And after carefully adding those up together, you get a final answer of 15.88 for all the outside sections of this figure.